In our experiment, we used the Fitt task to investigate the impact of noun categorisation on performance in terms of speed of the system and information processing. The Fitt task is a simple perceptual motor task that measures visual processing and motor control. In this experiment, the Fitt task was informed by Hicks' law, which is a theory that dictates the function of bits of information on reaction time. For reference, a bit of information is the amount of information required to reduce uncertainty by half. There were 4 participants involved in the experiment. As stated before, our manipulation was asking participants to attribute randomised words to the 2 themed categories of fruit and sport. This manipulation was selected due to its non-invasive nature, allowing for minimal control methods to achieve reliable and valid data. Also, the manipulation was convenient and was structured in such a way that enabled for a general interpretation for a lay audience. Lastly, we had minimal ethical concerns regarding the use of this manipulation, and any that arose were justified by the voluntary consent provided by each participant. Our experiment began by briefing participants on the purpose of the experiment, followed by explaining what was required of them during the exercise. Participants' responses were timed and recorded. As you will see, all participants' responses were documented on film. Not only were the order of the words called out randomised, but the order in which the levels of the baseline and manipulation stimuli were delivered were also randomised. In terms of controlling the conditions of the experimental environment, there were some considerations due to the fact that we were undertaking the experiment in different locations and at different times. In order to offset this issue, we attempted to generalise the requirements of the experiment setting to ensure uniformity. The adaptations we prescribed included the use of a stationary chair and a level bench top, with participants being asked to sit in an upright position to refrain from leaning on the bench. The research team all used the same words, which included 80 items equally divided between food and sport. We all used the same online randomizer to produce a randomised set of words that would be posed to each participant. Participants were all asked to perform the exercise with their preferred hand, with target sheets being fixed to the table to prevent displacement. Participants were then instructed to begin with their pen on the start box, and at the word go, begin tapping between the circles as rapidly yet as accurately as possible. An accurate response was categorised as one that hits the target in the target area, and on the occasion of missing the target, participants were asked to repeat the trial. Each condition, containing 30 trials divided into the 5 bits exercises, was preceded by a practice trial. The results of the experiment from the first participant revealed a baseline slope of 0.152, indicating a steady increase in reaction time as the level of difficulty of the task increased. From the regression equation shown, the value of the intercept at -0.09 strays from the general results expected from this task and can therefore be attributable to a number of separate factors. In addition, as our experiment did not involve testing our participants' reaction time for 0 bits of information, we are not able to confirm that the value determined from extrapolating backwards on the regression of the value of y at 0 would be that in reality. The R-squared value produced suggests that 89% of the variance in the data was accounted for by the linear regression. Without the manipulation, it was predicted participant 1 would be able to process 7.17 bits of information per second. The manipulation slope of 0.1437 demonstrated an increase in reaction time. The regression of the manipulation produced an intercept of 0.0093, which illustrates that at 0 seconds, this is the amount of bits of information that could be processed by participant 1. The R-squared value generated for the manipulation shows that 98% of the variance in the data was accounted for by the linear regression. With the manipulation, it was predicted participant 1 would be able to process 6.89 bits of information per second. The reduction in the extent of information processing in manipulation compared to the control is consistent with the findings of previous research. The second participant's performance resulted in a generated baseline slope of 0.1197, demonstrating a gradual escalation in reaction time as the level of difficulty of the task increased. The baseline regression equation produced an intercept value of -0.0957, which again deviates from the expected findings and can therefore also be attributed to alternate factors. The R-squared value indicates that 91% of the variance in the data was accounted for by the linear regression. The baseline results predicted participant 2's ability to process 9.15 bits of information per second. The manipulation slope of 0.1451 can be observed as a more notable increase in reaction time compared to the results for participant 1. The intercept of the manipulation regression of -0.1621 reflects this deviation. The R-squared value for the manipulation illustrates how 96% of the variance in the data can be explained by the linear regression. With the manipulation, it was predicted participant 2 would be able to process 8.01 bits of information per second. The reduction in the extent of information processing in manipulation compared to the control supplies further evidence for the findings found in previous research. The baseline slope produced from participant 3's results indicated the baseline increased at a positive rate of 0.0871, intercepting the y-axis at 0.1379. The R-squared value indicates that 91% of the variance in the data was accounted for by the linear regression. The baseline results demonstrated participant 3's ability to process 9.9 bits of information per second. The manipulation slope suggested a positive increase rate of 0.0434, with its y-axis intercept at 0.5236. The R-squared value indicates that 51% of the variance in the data could be explained by the linear regression. With the manipulation, it was predicted participant 3 would be able to process 10.98 bits of information per second. The elevated surge in information processing and manipulation compared to control of participant 3 was an unexpected finding and actually challenges the results of our previous participants as well as the breadth of the current research. The results from participant 4 revealed a baseline slope of 0.0886 with an intercept of 0.0714. The R-squared value indicates that 94% of the variance in the data can be explained by the linear regression. The results from the baseline condition illustrated how participant 4 could potentially process 10.48 bits of information per second, which was the greatest effect compared to the other 3 participants. This could perhaps be considered an implication of age, as participant 4 was the youngest in our sample and could therefore demonstrate a more efficient reaction time compared to our older participants. The manipulation slope of 0.1023 again illustrated a positive increase rate with an intercept of 0.0307. The results from the R-squared value implied that 93% of the variance in the data was accounted for by the linear regression. With the manipulation, it was predicted participant 4 would be able to process 9.48 bits of information per second, which is in alignment with the current research. On examination of the data we collected, the effect of the manipulation on the overall speed of the system and its impact on the information processing rate of each participant was evident. It therefore closely resembled that of what is theorized in Hicks' law. We were able to infer based on our study findings that both the speed of the perceptual motor system and the rate of information processing were affected by the unique manipulation method of asking participants to categorize groups of themed words into their respective label. We acknowledge that some level of bias was introduced into our study as the participants were all somehow related to each individual of the research team. In addition, despite controlling for the experimental setting as diligently as possible, we understand that the experiences of all 4 participants would have been characterized differently. As the experiments were conducted on our participants in comfortable and familiar surroundings, this would have led to them developing a more relaxed and informal response to the task. Through filming the participants during the course of the experiment, this could have potentially contributed to altered performance. A further implication for the nature of this study was that there would have been potential conflicts of interest, in that the familiarity between the research team and participants could have influenced their attitude towards their involvement in the experimental tasks. For example, a level of competitiveness was observed in some of the participants' approach to the task, which could have played a role in the results obtained. Also, the individual demeanour of the participants could have potentially influenced their capacity to perform at an optimal level, with them being in the extremes of emotional arousal being a possible concern. Age also raised probable research implications, as 3 of the participants belonged to the 50 years and above age bracket, while the remaining participant was situated in the 20 years age bracket. This could have implicated our results in such a way that could have skewed the findings in favour of the perceptual abilities of an older population sample. Furthermore, external distractions, including minor noise, could have influenced the attention of participants and therefore potentially compromising responses. Extending the sample size of participants is recommended to improve reliability, validity, and generalizability. For future studies, it's recommended that researchers recruit participants that are unrelated and unknown to them to increase objectivity and the reliability and internal validity of the study. We would suggest priming participants with the requirements of the study prior to the official undertaking of the experiment. Additionally, it is important that participants partake in the experiment within the same standardized and consistent environment to limit the influence of possible external factors.